Hi everyone, welcome back to Guide to SOLIDWORKS. Now today I am going to be putting on a very basic tutorial into the use of the simulation software. So it's just going to be really around the use of actually how we set up a very basic simulation. I'm not going to be going massively into all the ins and outs of the simulation information that we pull out of it in particular. It's more just how we set up a basic simulation and get some very basic data out of it. So first of all, we're going to create a small model. So I'm going to create a sort of like a cup holder sort of shape. Now, to do this, I'm going to start on the top plane. And I'm going to create a sketch. And I'm going to create one circle, give it some size. Let's say that's 80 mil wide. And exit that. And then from the top plane, I'm going to create another plane, and I'm going to flip the offset to that, and I'm going to go down, say, 100 mil. How far is it? Yeah, say 100 mil. Okay, and from there, on that second plane, or plane 1, I am going to sketch a second circle and set that at a size of around 50. Okay. Now I've created them two sketches, I'm just going to loft between the two. So between there and there. Let's get that nicely lined up. Okay, so we've got our shape. Now all that's happened there is that if these twist, what happens is it twists the shape of the component that you're lofting. Because I've not put guide curves in, it's used its own starting end constraint here. So I'm just going to keep them roughly lined up. Okay, and tick there. Now I've got that, I'm just going to shell out the inside, so shell the cup, and I'm going to leave it with a material thickness of around 3 mil. Like so. Okay, and then from the right plane, again, I'm just going to create another plane, and I'm going to come out around 60 mil. Okay, and then I'm just going to create on that plane using a center line, so I'll sketch on there, and I'm going to use a center line to just create a center of effectively like a pin that's going to stick out to hold the cup holder at the side. So let's say that's going down 10. Okay. And I'll give that a distance across the bottom of 30, like so. And I'll extrude that up. So extrude that up to the surface here. So I've got a very basic model there now. So what I'm saying is this container in here, whether it be a cup holder, whether it be whatever it is going to hold something inside here, and this will be attached to a fixed point on the end over here. So from this model, let's hide these planes so they're not in the way. I am going to use this to create my simulation, or simulate this cup holder itself. So if I come to my tabs, right click on the tabs, make sure that we've got simulation there ticked, okay, and that will pop up across the top. Now what I'm interested in setting here is a study. So I'm going to start a study. Let's say, just call it cup for a quick run. Now, We've got different types of studies we can use. We've got thermal effects, fatigue, we've got drop tests, pressure vessels, but the one that I'm going to be using for this is a static. I'm going to act as though there's a force acting down on the top. This is fixed in place. I'm going to see the stress on the material and the displacement in the material. So static test, make sure that's highlighted in a grey colour, and I'm just going to tick there. Now it's going to ask me to apply some things. To be able to run a test, it needs data about the material it's working with. So I'm going to have to apply a material. So I'll click on there. And I'm going to say this is polymer based, so let's go for an ABS. So I'm going to apply an ABS. Okay, I'll close that. Now I need to define where it's going to be fixed. So if I go to fixtures, drop down that. I want a fixed geometry, it's going to be fixed in place. We could have hinged electric supports. There's a few different ways you can do it, but I'm going to say it's a fixed geometry. I'm going to say it's fixed on the end of there. So I click that, it brings up all the green arrows showing where it's fixed. And then, if you're ever unsure, it also shows you a diagram at the side of how this works. So the green face is obviously the face that you're fixing, and an example of what might take place. So I'm going to tick at the top. Now I've got the material and the fixture in place, I'm going to apply a load. So I'm going to apply a force in this case, because it's going to be something acting directly down. A torque would be a twisting force. Pressure, we can do gravity. If we're doing force, though, it includes gravity, because force is mass times acceleration or gravity. So therefore, it includes that. So I'm going to click on force. I am going to click in the bottom of this container, as though it's pushing down on the bottom. And then I need to apply a force to the situation. So let's go, let's go 20 newtons. About 2, which is just under 2 kilograms, just over 2 kilograms, just over 2 kilograms in force on the bottom of there. So we know it's going to be, the container's probably not going to be able to fit 2 kilograms of material in there, but we're just overemphasizing the force that's going to be acting. Okay, so I tick there, and now we've got our force applied on there. Now at this point, we need to apply a mesh to the material. Now the mesh is what is going to calculate what is happening. So down the side here, this has been putting all my data as we're going. I've got my fixed point, I've got my material, I've got my force, and then I've got a mesh. So if I right click on that mesh, and I go to create mesh, and then I can set how coarse or how fine I want that mesh. Now what this is going to do is, the finer I do it, the more it's going to work out. But that's generally only useful for components that are quite complicated. With this being quite a simple component, I could go over more coarse mesh. So I'm just going to go somewhere around there. The more fine you make it, the longer it will take to simulate, because it's got more points to work out and calculate. So I'm just going to stay up here somewhere. I can alter my mesh parameters if I want to. I can change certain information about them, but I'm not going to do that for this sake. So I'm just going to tick there, and it'll apply that mesh. So what I've got, as you can see if I zoom in, is all these little triangles. Now the points in which all these triangles meet are called nodes. They are all the points that all the data is taken from. So the stress that's acting in the material, the displacement that's acting in the material is all calculated across all these little points. So obviously the finer that I make the mesh, the more of these points there's going to be, so there's more to calculate. Which means if I want my calculations to be very precise, I would have a finer mesh. If I've got a really complex shape, again, I'd have a finer mesh. Okay. So now I've got my mesh in place, I can run my simulation. So to run the simulation, if I go up to run at the top there, click on run, and it'll start to run the simulation. And with that obviously being quite a simple component, a simple simulation, it's pretty quick. Now, these, depending on how complex your model is and what you're simulating, can take quite a long time and quite a lot of processing power. So in terms of a basic simulation like this, you'll find pretty much with any computer that's able to run SolidWorks. When you get to more complex things, as we develop, you will find that some computers may crash as you do that process, or it takes quite a long time. But what we've got here is we've got a color scale to our model now. So the blue is showing where our low stress points are, and the red is showing high stress points. So for instance here, pretty common that we'll find high stress points around joints or sharp edges, like this. But I'm not overly worried about these stress values. Even though it's in red, it's not a massive worry. It's coming out at 2.647 times 10 to the 6. Okay, now if we check the material information, so if I just go to apply materials again, and I found the tensile stress, or the maximum, so the maximum tensile stress of this material is 30 times 10 to the 6. So I'm way under that. I'm way under that value. So that's not a worry to me. The only thing it's showing me because it's red is that's just the high point on the material. We can do the same for displacement. So if we just double click on displacement, it will show us where the most movement in the cup is going to be away from its original shape. So here we've got 3.446 times 10 to the minus 1. So, and that's in millimeters. So it's 0.3 millimeters a movement in the bottom of the cup when there's 20 newtons applied to it. So again, not a lot, but again, it's showing in red because that's where the most movement in the cup is. So don't automatically think just because it's red, it's bad. Not necessarily the case. It's just red because that's where the most movement in the cup in this object is. Okay. So that's a run through of how a basic simulation works and how we can read off some of the data and what the data means. So that's a basic stress and displacement data. Hope that's useful. Hope that's a nice little introduction into using the simulation software. And we'll have a look in the future at doing some more complex things. Have a go, have a practice, and try and implement this yourself into something that you've been working with. I hope you've enjoyed this video. Hope you like the content. Give us a big thumbs up and subscribe. That always helps the channel and helps me to continue to produce more and more content for you. And we'll see you in the next video. Bye now.